Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're going to get section 4.7 and some general strategies of factoring. If you haven't seen my previous videos, I would look at those first because I talk about the different types of factoring. One such type is factoring cubes, and I come up with a definition. In order to factor cubes, we write down the bases. So in this case, x and y are a base. You square the first, you take the product, you square the last. First you keep this sign, then you change it, and the last one's always plus. Remember, you can do that for sums and differences of cubes. So watch some previous videos for some hints. We also discussed, besides sums and differences of cubes, how to factor a difference of two squares. Remember, you cannot factor the sum of two squares, so you would just write the word prime or not factorable. If they give you something like x squared plus 9, you cannot factor that. And some strategies are to always look for the greatest common factor first. If there's two terms, we're going to look for difference of two squares. That would be like x squared minus 9 factors to x plus 3 and x minus 3. But remember, it's got to be the difference of two squares. If there's three terms, watch a previous video where I talk about how to factor trinomials and some strategies for that. I'm not a big fan of the AC method, but if you want to follow the book's examples, those are posted on videos as well. If there's four or more terms, we're going to try to factor by grouping, and I'm going to show you some special types of grouping in this video today. Factoring always means factor completely, and remember, you can always check by multiplying your answers back together to see if you get the original problem. So let's take a look at some examples. Looking for the greatest common factor, I believe 18 and 27 is divisible by 9, but there's also some y values here that are common, so I would pull out or factor out a 9 y to the 8th. And literally what that means is you're dividing each term by 9y to the 8th. You don't need to write this red step, but that's actually kind of what I'm thinking, so that when I start canceling, I'm left with 2y and minus, well, all of these y's cancel, but 27 divided by 3 is 3. And then I look to see if I can factor some more. If I factor it completely, then I'm done, and I believe that I am done in this case. And then the author of this took the time to went ahead and distributed to check to see if you could get the original answer. So that looks pretty good. Difference of two squares. Looks like I could factor this as, let's see, if I rewrite it as m cubed, this thing being squared, and 1 is being squared, I can see the difference of two squares. So just like I were to do x squared minus 9, I would factor this x plus 3 and x minus 3 because that's what's being squared. X is being squared, and then this 3 is being squared. I'm going to do the same thing here. M cubed is being squared, and m cubed and 1 is being squared. The signs are different, so one's a plus and one's a minus. And now I have cubes. So all of this in blue, I write down the bases of what's being cubed because 1 is being cubed. I square the first, take the product, square the last. First you keep it, then you change it. Last one's always plus. And then over here, I have cubes again. So you write down the bases. Just like we did in the blue, you write down the bases, you square the first, take the product, square the last, but first you keep this sign, which is negative, then you change it, and the last one's always plus. So I think the final answer looks a little bit long. It looks like the author got the same thing, though. So this is our first trinomial. Let's remember to factor out the greatest common factor, which is a 2, so I'm going to divide each term by 2. Giving me 2x squared minus 7x plus 6. And remember, you need to watch some previous videos on how I would recommend. I don't do the AC method, so you can multiply the 2 and the 6 together and get large numbers, but I'd rather list factors of the first and the last and list the factors out and look for factors that add up to 7. So I need factors of the outer and the inner to add up to 7. It looks like right here, 2 times 2 is 4, forcing the 1 and the 3 together, which is 3, and this 4 and the 3 adds up to the middle term. So these loops are my outer and my inner terms. So when I go to place numbers in, I'm going to use the only terms I can use, 1x and 2x. I think the most important line that you could possibly draw here is this line, which represents outer terms. And look, 1 goes to a 3. And I've done all the work over here. So all I have to do is put the 1 with the 3, forcing the 2 to go with the 2. Signs are going to be alike, and they're both negative. If you didn't like this process, what I did, again, you could watch a previous video, which I explained several examples of how to factor trinomials. So here's how the author worked it out. They didn't really show much work, but they have the same solution. So when you see 4 terms, I generally like to try to factor by grouping our first 2 terms. So let's pull out a 3, because that's the greatest common factor, leaving with an x plus 4. And then I immediately write down another x plus 4 in the hopes that whatever number goes here in this red bubble, and I multiply, I can get what's remaining. So in order to get an ax squared, I need another a and another x. And then I'm going to check it and see if this ax times this 4 gives me a 4ax, and certainly it does. Now if it didn't, I would have to try to regroup in a different way or try synthetic division, which I haven't even taught you yet. This looks pretty good though. And now I have a GCF of x plus 4, so I'm going to factor out an x plus 4, which literally divides that out, and it's going to leave me with 3 plus ax. And I put a plus sign in here because I wanted a positive ax term. So here comes my final solution. By the way, I need these parentheses, otherwise that means actually something different. Let's see if the author agrees. Yes, they do. Let's practice that again. If I try the first 2 terms right here, I don't even have a GCF. So I'm going to switch gears and try to factor a little bit differently. I showed you in one video we could put maybe the m squared and the 49 together and then see if we have a common factor between here, but again, I don't think that's going to work either. So instead, I think I'm going to take the first 3 terms, which is something new. I don't believe I've shown this to you before. If I try to factor out the first 3 terms, or excuse me, just ignore this plus 49 in a moment and try to factor this trinomial. And this trinomial says I need the first term to be m and m, because that's the only thing that's going to give me that m squared. I need factors of 14. Let's reorganize this. So this is really m squared plus 14m minus 4b to the 4th. Well, that's not going to work either. So it's okay for you to see me struggle here, because you're going to struggle too. So I picked this 49 out here because I knew it was a perfect square. Unfortunately, I think I need to use that 49 in order to factor the yellow. So I'm actually going to pick my minus sign out here, and the 4b to the 4th, which is also a perfect square. So usually a perfect square goes here. So what I'm trying to do is get yellow to be a perfect square and the 4b to the 4. So that means I can use the 49 here. So I'm reorganizing this thing. Oh, sheesh. So I've rewritten this. M squared plus 14m plus 49, and I'm going to group that together and say minus 4b to the 4th. So now I'm going to try to factor this yellow. And this yellow factors to factors of 49 that differ by 7. This is a plus now. Good. Factors of 49 that add up to 14 are 7 and 7. Signs are alike. They're both positive. So m plus, there we go. So now I've got a perfect square. M plus 7 squared minus, let's write this as a perfect squared as well. This is going to be 2b squared times 2b squared will give me the 4b squared. So now I have the difference of 2 squares. So m plus 7 is being squared and 2b squared is being squared. So I'm going to factor this like I do for the difference of 2 squares. M plus 7 is my first term. 2b squared and 2b squared as my last terms, and signs are going to be different. One's a plus and one's a minus. And I think I'm done. I can't combine any like terms. That was a very difficult one, and it looks like the author got the same answer. Looks like he used the same method. Let's try it again. If I try to factor out the GCF of the first 2 terms, I don't even have a common. So then I could try to factor the first 3 terms or reorganize things, and I definitely like that 36 to be last this time because that's a perfect square. So let's try to find Well, that's not going to work either. So there's another perfect square right here. I wonder if I put, let's reorganize this. Y squared plus 12y plus 36. That 36 keeps tricking me because I keep thinking that's going to be my perfect square at the end. But 9a squared is also a perfect square because I can write it as minus 3a quantity squared. So I'm looking for another perfect square in here, and I think I found it. This is y plus 6 and y plus 6, factors of 36 that add up to 12. So that's y plus 6 quantity squared. So this is the difference of two squares. I can write that as y plus 6 times y plus 6, and 3a and 3a. Signs are different. One's a plus, one's a minus. And again, I think that's the final solution. You can check by multiplying that back together, but that's a long process. I hope you found this video helpful. Email me with your questions. Have a good day.